Engine Performance 1 Test 10, for the ones of y'all that are here. Temperature and position sensors, we're going to whip through this pretty quick, if we can. Technician A says all temperature sensors are positive temperature coefficient devices that decrease in resistance as the temperature increases. Technician B says some vehicle manufacturers use a stepped engine coolant temperature circuit inside the PCM to broaden the accuracy of the sensor.
B.
That is B. Now, I'm going to tell you, I do not know personally of a temperature sensor used in a computer system that is not positive temperature coefficient. Excuse me, negative temperature coefficient. So PTC gets hotter. When it gets hotter, it's got more resistance, like a light bulb. And the negative temperature coefficient is the sensor that actually has the tendency to reduce its resistance. Technician A says, other temperature sensors that operate like the engine coolant temperature sensor include the transmission fluid temperature sensor, the cylinder head temperature sensor. Technician B says all temperature sensors increase in resistance as the temperature decreases. That's A only. The temperature sensors are typically always going to be negative temperature coefficient, which means they reduce their resistance with heat, which is the opposite of what you'd expect. And that's the way I always remember the difference between negative and positive on those. I will tell you this, sometimes your brain can get tangled up looking at these words and you can actually say something that's backwards, and sometimes that happens to me. The sensor that measures the temperature of the air being drawn into the engine is called what? IAT, NTC thermistor, PTC thermistor, both A and B.
I say it's the intake air temperature.
Intake air temperature sensor. Is that right? But is it negative temperature coefficient?
No. I know.
It's not PTC, it's NTC. So that's going to be both A and B. That's going to be a D.
Oh, that's not fair.
I know. That's a trick question. It'd be real easy to miss that because instantly you're going to say IAT. Because who in the Sam Hill calls it an NTC thermistor?
Yeah.
You know what I'm saying? Who calls it that?
Not me.
All right. So, incidentally, you guys could learn something from Lundy, because Lundy was sitting in here plugging away at these worksheets on that. See them boards there? Lundy was working on them boards there yesterday, and he knocked those things out in short order, didn't you, Glenn?
Yes, he did.
How long did it take you?
I was done by lunchtime.
Yeah, it was easy. Wasn't a lot to it. You guys can knock that out in a flash. A diagnostic trouble code P0013 is being discussed. Have you ever discussed a diagnostic trouble code with anybody?
I have.
Have you ever been referred to as Technician A or Technician B?
I have not.
Oh, well, you will be by the time I have to get through writing tests. Okay. Technician A says the intake air temperature sensor could be internally shorted to ground. Technician B says the PCM could be defective. Who's correct about that?
I don't think the PCM's going to be defective. Then you can get the DTC.
Well, let's see. Is the IAT sensor internally electrically short? Believe it or not, the PCM could be defective.
Just throw in a bad code?
Yeah. Well, you got to know what a P0113 is.
I don't know what P113 is.
I mean, not P013, P113. So what does a P113 mean? In order to answer that question properly, you'll have to know what a P113 is.
That's not the coolant temperature sensor, is it? No.
The 118 is the, hey, Willie, you're 2 hours late. You must have to wait for Joe or something.
No, not this time. I was the one that was late.
Who told you it was spring break this week? I know how slippery
He told
Joe
us.
is. Joe says, I'm going to act like it's spring break this week and then I'll get a 2-week holiday. That's what happened there.
No, that was actually accidental.
What you need to do whenever you're not sure if it's spring break or not is you say, I need to ask my instructor if it's spring break, else I may make a mistake. On that.
That'll work.
Yeah. Or somebody will say, look, I was thinking about hiring this guy here, and they're just, tell me your name and all that kind of stuff. And I say, what can you tell me about him? I said, well,
He doesn't know when spring break is.
one thing that I do know about him is he loves to sleep. He loves to sleep.
I wasn't sleeping.
He
I
stayed-
wasn't home.
He
My
stayed,
coach come by my house. He don't ever come by my house.
yeah. Well, anyway.
And on Monday, he came by and beeped his horn. I get dressed, I run out the door, he's gone. So
Yeah.
you know what I thought? Hey, I must have been just dreaming that he came by or something. It's spring break. Why?
Yeah.
He's not even here.
So that means you were sleeping. Okay, let me see here.
Yeah, like
Suffice
8
to
in the morning.
say that number 4 is B, okay? That is technician
What's
B only.
113?
113's got to do with the intake air temperature sensor, but whether it's open or shorted See what I'm saying? You got a code for open, a code for shorted. And so if you're looking at the different, see what the code is.
So it's an open.
Yeah.
113 is an open.
Yeah, somebody get your smartphone out and find out what a PO 113 code means. Look at all them smartphones coming out. Yeah, PO 113.
What
Yeah,
is
that's
a PO 113?
Yeah, what is a PO 113?
P01.
While you're doing that, we're gonna move on to the next question. Just, somebody can find it.
Has to do with the powertrain.
Yeah, obviously. All right. A diagnostic trouble code PO117 DTC is being discussed. Technician A says the ECT sensor could be internally shorted to ground. Technician B says the signal wire could be open. Who's correct about that?
The 117 is an oxygen sensor.
No, 117's got to do with the coolant sensor.
Wait a minute.
Where are you coming up with an oxygen? You talking about 171?
171.
Yeah, 171 is what you're thinking about.
Yeah.
That's a little dyslexia going on there. All right, all right, I've got, what we got there? Number 5. 5 is A. You finding it, Joe? All right, finding PO 113?
Yep.
Yeah. What's it telling you? What's the name of it?
I'm
What does it
just-
mean?
I'm waiting for the internet to connect.
Yeah. All right.
Both of them is right.
Lundy's got his machine working over it too. Yeah. Well, actually on 5.
Intake air temperature circuit high input.
That's what I'm just.
Now, what does that mean? What does high input mean?
When it gets a signal greater than 5 volts reference.
Does that mean it's shorted or does that mean it's open? If I touch that wire to ground, which way is that voltage going to go? Is it going to go high or low?
It's an open in the IAT ground circuit or signal circuit.
All right, now look at our question. Internally shorted to ground? No, that's not right, is it?
Nope.
Okay, but your PCM could be bad, causing it to throw you that code.
It says faulty PCM, less likely but not impossible.
That's right. That's exactly right. Although I'm not sure if you're reading from that or not. Okay. An intake air temperature sensor is being tested after the vehicle has been allowed to cool for several hours. A scan tool is used to observe the intake air temperature reading. And when compared to the engine coolant temperature, the two temperatures should be within how many degrees of each other?
I'm gonna say 5 degrees.
Really close, and that's one of the things you do, and I've talked about this before. If you go over here and you plug your scan tool in and you compare you just switch on the key, don't start it up, just switch on the key, look at your transmission oil temperature sensor, look at your engine coolant sensor, look at your intake air sensor, they ought to all be reading the same if it's been sitting there all night. Why is that?
It's the same temperature.
What law is it that makes that? What scientific law is it that is in play here that causes all of the sensors to read the same after it's been sitting all night?
Law of thermodynamics.
Second law of thermodynamics.
No.
Who?
Who?
Melissa?
Who are you looking for?
Melissa?
She isn't here yet. I think she had sent me a message and told me her little boy had a sore throat and she might be late because she had to go to the doctor with him. What do you need?
She was gonna come over to cosmetology and I was gonna do her hair.
Oh, fiddle. Well, when she gets there, I'll remind her of that. But she did say that she would either be leaving early or she'd get here late, and obviously it's late.
Thank you.
Sorry about that.
I need a haircut.
Yeah. Oh boy, everybody needs a haircut now for some reason. I don't know why, but all right. Let me see. Let's see. A corroded connector at the engine coolant temperature sensor could cause what?
All of these.
All of these: a stored DTC, air fuel mixture too rich, poor fuel economy. Why would it cause air fuel mixture too rich?
Because the engine coolant temperature sensor is the master of all.
No, it's not.
Boy, that sounds good, doesn't it?
Yeah. It actually has a lot of priority though, whenever, especially like when you start it up. You remember I told you guys that story about that Dodge truck that we came into the body shop, and this is an important story, so pay attention even if you've heard it before. Comes into the body shop, and whenever it's warm weather, like it comes in the spring, in the summertime, and and so they have to do about $11,000 worth of body work on it. I mean, it's really a bad deal. So they put it all back together, and I'm over there helping them, and this thing is really it's cold weather out there now. It's 40 degrees. So I'm sitting there. I go out there and I get in it because they want me to see why it won't start. Because it was starting just fine until this cold snap came. So I go to start it up and I'm smelling gas. So I pull the plugs out and they're all wet. I said, well, maybe they've cranked it and drove it around, until they've wet the plugs. And I did have an intake air temperature sensor code, but I didn't think a lot about that at the time. So I pulled the plugs out and they were soaking wet with fuel. So I got the plugs all dried out, popped them back in there, whatever. I may have put new ones in, I don't remember. But anyway, I started spinning over and immediately smelled gas again. So I'm looking at the DRB2 or the DRB3, and I'm seeing that the engine coolant temperature sensor is reading 46 degrees or whatever. I'm shooting a figure real close to that. But my intake air temperature sensor is reading 101 degrees. And this thing's been sitting there. You remember what I told you? Pay attention to all of them. They ought to be reading the same if it hadn't been running. Because when you run, you make heat and it changes the sensors. Okay, this right here, the calculations, this was in my, incidentally, this was in my, my room, my enhanced room for Chrysler in Dodge, okay? In this, you got two rooms. You got an OBD2 room, you got an enhanced room. You gotta look in both of them before you're gonna get a real picture. If I look in the OBD2 room, in the same situation, this one right here is saying 46 degrees, and this is ECT. IAT is reading minus 40 degrees. Now, why is it that IAT is reading minus 40, and this is OBD2, you know, the generic, and this right here is enhanced?
It's because it sees that it's not reading anything, so it's just plugging a number in there.
Bingo! That's exactly how it works. And I tell you something else, it applies this to its algorithm to determine how much fuel to put in there. And so it's saying if I've got air that's 100 degrees, and I've got, you know, coolant that's 46 degrees, I need to put this particular air fuel mixture in there, and it wasn't right. That's the problem. I was saying, now let me tell you what I did. This is what's cool. I got my little potentiometer, and I got, you know, a little potentiometer is like this thing right here. Where in the Sam Hill is it? I'm always wanting to wave one of these in front of your face. A little pot that was laying here on the table. You know, it's a little potentiometer. It's got three little terminals on it. Okay, so you turn that thing, you hook it up to two of them terminals, and you unplug your sensor, right? And then you plug this little, you put wires into your little sensor, you know, where the harness is put in the sensor. I'm gonna put that little potentiometer in there, I'm gonna watch my scan tool, and I turn that knob until this number matched that one. Now this is like a, you know, 50,000 ohm pot, right? So I turned it through until I got that. You can buy those little potentiometers at Radio Shack for dirt money. They don't hardly cost nothing. And you could hook a couple of wires up to it, and I match those two numbers, whoom, fires right up. That's all it took. You got me? Now that's really important that you recognize how those numbers are plugged in by the engine controller and how they work. All right, now then. That's a pretty interesting little story that you've probably heard me tell it before. If you watch my YouTube channel, I think I've told it 2 or 3 times, but it's really important to understand. Okay, now then, wiring to the IAT sensor has high resistance. What could this cause? Well,
I don't think it's going to cause black exhaust smoke.
Well, I will tell you that that really is not a great question because the programming that is typed into the engine controllers on various vehicles cause various different problems. Now, let me explain what I mean by that. Back in years ago, back in the early 80s, when they first started putting fuel injection on cars, Cadillacs and GM cars and all this, and Fords and all, they had a little intake air temperature sensor right there in the manifold next to the throttle body.
Whoopsie.
And that wasn't really such a big deal until all this PCV sludge compromised the thing and we'll end up getting it made and open up. On those, if that sensor opened up, like if you unplugged it or if it went open, it would pump fuel in there and black smoke and just soot up everything. Poor fuel economy. However, and I sort of plugged that in. You know, when I learned something like that when I was early in this business, I would plug that in as the norm. Okay, but what I found out was, and like I say, this right here is an example of how the intake air temperature sensor can cause crappy stuff to go on. What I was just telling you that story. But on some vehicles, all it does, it doesn't have the priority that it does on some others. Like on some of your Jeeps, whenever we were learning about the Bendix fuel injection that came out between 87 and 90, the instructor in Atlanta, Dick Kennedy, he said, on that particular one, if the intake air temperature is open, it'll just stumble like the accelerator pumps bad. So it won't affect the fuel economy. That's what we were told. And I couldn't unplug that and see anything change a whole lot on those. So the priority that it's given by whoever typed those algorithms is gonna have a lot to do with how it reacts. Now, on the average, if either one of these sensors is open, you're probably gonna see some fuel economy and rich running issues, so just be aware of that. But it's not gonna be, you can't, one size does not fit all. You got me? So just be careful that you
So
understand.
we going with C then.
On that, well, if you're gonna, the test that's, our textbook writer put together is that. So, that's gonna be A, it's gonna be a C, yeah. Okay, Technician A says the purpose of the intake air temperature sensor to provide the engine computer with the temperature of the air entering the engine. Technician B says the intake air temperature sensor information is used for fuel control, which is adding or subtracting fuel, and spark timing depending on the temperature of the incoming air.
See, they're both right.
Which technician is correct? Yeah, both those guys are right. Let's work our way through this. Okay, let me see. In the illustration below, what type of circuit is depicted? In the illustration below, what
Broken.
type of circuit is depicted?
Oh, yeah, I was looking at the wrong thing.
You got a step-up transformer, a positive temperature coefficient thermistor, an oxygen sensor, or a negative temperature coefficient thermistor. That's a D, isn't it?
Yep.
You notice the way this thing is drawn.
Higher one, cold, lower one.
All right, now watch this. You guys need to understand this because you're kind of an electrical too. Let me put my yardstick away. All right, you see that right there? I want you to watch this. That little part right there is what you call a current limiting resistor. Okay, you notice that this is fed out to the sensor, and you got a ground back inside the computer. That's your signal return, and this is your voltage for that thing. So that we'll look at where it's taking a signal from. It's taking a signal from right before the current limiting resistor. And so basically that's how just about all of those things are set up. Now, in the PCM, on the ones that have a stepped one, a stepped resistor, you got some other circuits in there. But that's a fairly simple thing. When you see that, and you'll see those on schematics, that's what you need to recognize, because that's how that thing works. This digital volt ohmmeter reading indicates a temperature of what for a GM engine coolant temperature sensor?
Well, how are we supposed to know that?
It's either A or B.
Well, one of the things that I always noticed, what do you think? The GMs are stepped. That's 70 degrees Celsius, is what it is. Now, who in the world uses Celsius?
What's Celsius?
Yeah, really.
Celsius is what those British people use.
British.
If I had a Perkins diesel engine that was built in England, and I was gonna grab either my metric tools or my imperial tools, imperial being inches and feet and all, which toolbox would I need to work on a Perkins diesel engine that was built in England?
I'm gonna go with, that
No.
standard.
Standard. Why? Because we got our inches and feet from England.
Oh, yeah.
Yeah, didn't we?
Wow.
I mean, I worked on Perkins diesel engines and everything was 9/16 and half inch and all that kind of stuff. Now, there are these Whitworth sizes that you get in some of these Craftsman tool sets that have the 475 pound. You have 17 30-seconds, 25 30-seconds. You seen those?
I've
Yes.
seen
Those are Whitworth sockets, and they masquerade as the 11/16 you're looking for, and it makes you want to go throw them away because they won't fit anything except old British motorcycles. You know what I mean?
I've seen those.
Did you guys see Cars 2?
Yes.
You remember that old Mater wrecker was saying, that thing's got them Whitworth sizes. They ain't metric, they ain't inches, they ain't nothing fits them. He was talking real. You know, that was a real deal. I wasn't making that up. That was automotively correct, the stuff that guy was saying. Now, having the miniguns that were on the side, that wasn't, but you know what I'm saying. All right. But anyway, that's 70 degrees Celsius. Now, one of the things that I found out when I was working on these Tauruses, I wanted to see if the fan would kick on when it was supposed to kick on. So I would take my meter and I would hook it to ground and I would back probe the engine coolant sensor, like a 95 Taurus when we was working on those, and I would crank it up. And I knew, because I had seen it happen, and I actually saw where they came on, I would watch that gauge, my temperature, my voltage on my meter, and when it got to, 450 millivolts, which is a little less than half a volt, it would kick on. And then it would run until it was like 520 millivolts, something like that, and kick off. If you get that pegged on a particular vehicle, and you're checking to see if the fan's coming on, if I'm watching this thing, and I see it hit that 450 millivolts, and it ain't coming on, I know we got issues. And you can also, on most of the new ones, you can go to the place where it tells you if the fan's on or not, and you can say, if it says, if the fan changes toggles and says on and the fan's not running, that's you're gonna be looking for relays and fuses and that kind of thing. So just be aware of that. That's why it's so important to go ahead and just gather your data from a lot of good vehicles, and that way you'll know when the smoke clears what's going on when you look at all the data on the other ones. If you're looking using a scan tool, if you're looking at a scope, one of the things that we were talking about up there in that scope class that I went to in Kansas City, and they made a good sense, you need to build you a library of scope patterns and store them in your digital storage oscilloscope's memory, so that if you've seen the cam and crank sensor on a car that's running right, you store that and you tell it, you know, this is '05 Nissan Altima or whatever. When you get one that's not doing right, you can measure it and compare it. And if you're using a Pico scope, you can drag those patterns on the same screen and compare them to one another. That's really cool. All right, the sensor that most determines fuel delivery when a fuel-injected engine is first started is the what? It is the engine coolant sensor when it's first started. After that, there's a lot of other stuff that comes into play. Modification. Now, let me explain something else to you right here while I've got a second to do it. When I'm spinning my engine over, my injectors start squirting. What's it looking at to determine how many times to operate those injectors? If it's a sequentially fuel injected engine where the injectors are following the firing order, now listen up, this is important. When I'm spinning it, it bank fires them because it needs more gas. If you've driven something with a carburetor on it, you're going to pat the gas and wet the manifold and close the choke before you start it, right? Or back in the 60s, we would pull the choke, you know, and then within a minute or so, it needs to go back in because you don't drive it with the choke pull because you don't fan the oil. All right, so here we are driving along, we're starting it up, and then whenever it finally fires up, it's just firing like this. Okay, so you might notice if you're paying attention, if you ever listen to the fuel injectors, most of you guys have out here, when you give it the gas, it goes, it's idling, it's going click, 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 your injector is. When you give it the gas, it goes click, 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 it picks up speed. Now what is it that determines it, what is it that it makes it decide to pick up speed? What's it looking for that?
Position sensor?
Well, the throttle position sensor adds some extra squirts because you still need an accelerator pump function on a fuel injected engine. But the crank sensor, as the engine speed picks up, it's going to fire it more often. Okay, now what determines how long it opens the injectors when they fire? Engine load, which is from mass airflow or MAP, is going to determine what your pulse width is. How loaded are we? How often we fire is operated, you know, is determined by engine crank speed, right? When we fire is determined by cam sensor usually. You know what I mean? The cam sensor is going to determine when it's okay. You really don't want to squirt some fuel in there until the fire's gone out, right? I mean, but now you are behind your valve, so you know what I'm saying. But if you've got some kind of an issue where there's a little bit of combustion leaking past the valve, you may wind up with a little induction backfire if it squirts when the fire's still in there. So that's what the cam sensor is about, right? And there's other things too. So basically, if you can understand that, if you can get your head wrapped around the fact that the frequency of the injector firing is tied to crank speed, the timing of the firing is tied to cam position, so it knows which one to start firing. Okay, the next thing you're going to look at is what modifies that pulse width. Engine load, I already talked about that. Intake air temperature and engine coolant temperature modify the load. Now, like I say, you're going to get some extra squirts. It doesn't just modify the pulse on the ones I've seen when you crack the throttle, because it's paying attention to how fast you open the throttle and how fast you're moving your foot and all that. And it's going to add some squirts in there. If you look at it on a little graph, it's going to go bzzz, it's going to buzz the injectors a little bit while your throttle is changing. That's why it's important not to do this. Let me tell you this. Watch this. Listen up, guys. This is engine performance class. You need to know this. If you start one up and the throttle position sensor is going stupid on you, and we're talking about that in a test that was going to happen at spring break, then it's going to add a bunch of squirts that's going to make it run really, really rich. Like if your throttle position sensor, you're supposed to keep your hand off your foot off the throttle when you're starting one that's fuel injected, right? You're supposed to. But if you're patting the gas, like if you see a throttle position sensor is supposed to be like this, right? All right. And I've seen this. Throttle position sensors wear out. They get old. And if you got a throttle position sensor that the engine controller is fast and it's doing this, and it may level out for a while, it's like supposed to do this again, it will run just as rich as a dog.
Remember my dad's throttle position? How it would just go boom, and then just
Yeah.
rev up again.
Well,
Is
something
that
else
what
it
that
does is it causes the idle air control to do crazy things and the timing and all of that. But I had Donnie was working on a van that had he didn't think it had data stream, but it did, you know, because of the tool didn't tell him it had data stream. It was acting like all you can do is pull codes. This right here was an in-range failure, and he never got a code. You know what I mean? If you're dependent on codes, then it's in-range failure. And he was saying, I've been fooling this thing for a week. When I crank it up, it just puffs out a bunch of black smoke, and then it runs pretty decent after that. Well, while you were spinning it over, when it was cold, the throttle position sensor was all over the place, and it was kind of hard to get to down there. And I said, well, you got data stream because it's got the wires going there. He said, well, it tells me I don't. And I said, well, tell it you got an E4OD transmission. He said, well, that ain't got one of those. It's got an AOD. I said, I don't care. Tell it you got an AOD. Lie to it. So he lies to the tool, and all of a sudden he's got data stream. Crap, I didn't know I had data stream. I said, well, if you got those wires going to the connector on this Ford, you got data stream. It was like an older one, you know, OBD1. Well, he looked at it, and sure enough, the TP sensor's bouncing all over the place, made it run rich.
Love that.
Okay, I just kind of got off on a tangent, didn't I? Okay, let me see here. All right, at least I wasn't talking about fishing. All right, here we go. Where are we at?
13.
Oh, yeah, we're actually doing TP sensors on here too. A PO122 diagnostic trouble code is received using a scan tool. This means that what? PO122. See there what it is.
Sensor.
That's
low
an in.
input.
Voltage low, shorted to ground. That's all above correct. What's not the function of a TP sensor?
Clear flood mode off of it?
Come on, clear flood mode's when you mash it all the way to the floor. Now, occasionally you'll run across a vehicle that doesn't have clear flood, so be careful about that. But
Torque converter clutch operation, isn't that the brake?
well, it's actually determining the rich and air lean fuel mixtures. That's actually your oxygen sensor's job. You got me? All right. So, okay. Technician A says the 3 wires on the TP sensor include a 5-volt reference voltage from the PCM. Technician B says the TP sensor is a 3-wire, a variable resistor called a rheostat. What? It's not called a rheostat. That's a bunch of hooey.
A.
Yeah. Technician A says the 3 wires. Wait a minute. Never mind. That was 16. Or is it? No. Technician A says the 3 wires on TP sensor include a 5-volt reference voltage, signal wire to the PCM, and ground, which would be called signal return. Technician B says that the TP sensor is used by the PCM to determine torque converter engagement and transmission shift points.
Both.
That is correct.
Where you at?
Both those guys. 16?
15 was A, 16 was C.
Yeah. 17, technician A says the TP sensor signal voltage should be about a half a volt at idle and increase to about 2.5 volts at wide open throttle. That's not right.
No.
Technician B says TP sensor can be tested using a digital multimeter, digital storage oscilloscope, or scan tool. Who's right about that?
B.
B only.
B is right about that. All right, you got that? So, which of these sensors could be used to check for a poor PCM ground? A, oxygen sensor, B, IAT sensors, C, TP sensor, or D, ECT sensor? That's gonna be C. And how are you gonna find a poor PCM ground? I'm gonna unplug that sensor. I'm gonna measure the voltage at all 3 of those pins. One of them should have 5 volts. The other 2 should have nothing with it unplugged. But what if I measure it and it's got 12 volts? That's a bad PCM ground. Got me? If your PCM is not grounded, your TP is going to read 12 volts. Now guys, if you're paying attention here, some of your final exams are going to contain circumstances like this. And you're going to be measuring voltages and looking at stuff and trying to figure out no starts and all this, and you will crash and burn if you're not paying attention. All right. So you need to burn this in and rewatch this lecture. Okay, a typical TP register about how many volts at wide open throttle?
4.5.
He's good, 4.5. Which of these components lets the PCM know how fast you want to accelerate?
TP sensor.
TP sensor. Which of the following is a 3-wire variable sensor? Potentiometer. Potentiometer. Yeah, the TP sensor indicates the engine's idling, but the map sensor indicates the engine's under a heavy load. That could cause it to set a code for the what?
Either A or B.
Either A or B. Good answer, Joe. All right. Now then, I'm going to kill